Okay, creating equations for sinusoidal applications. Okay, so when we see sinusoidal, we just mean sine or cos, right? They take on like the same characteristics. They have the same properties. Okay, they follow the same set of rules. So this just means sine or cos. Okay, to test the resistance of a new product to temperature changes, the product is placed in a controlled environment. The temperature in this environment as a function of time can be described by the sine function. So this one's telling us to use the sine function. The max temperature is 120. The min is -60. Okay, both degrees Celsius. And the temperature at time equals 0 is 30. So we actually have a point, 0, 30. It takes 24 hours for the temperature to change from the maximum to the minimum and back to the maximum. Okay, what that means, if we go from max to min, back to max, that's actually the period, 24 hours. Okay, if the temperature is initially increasing, so we're starting at this point here and we're going up. What is the equation of the sine function? That describes the temperature in this environment. Okay, so we know we need amplitude, which is max minus min divided by 2. So 120 minus -60 divided by 2. So that's 180 over 2, which is 90. Okay, and then equation of axis is going to be max plus min divided by 2, which is going to be 120 plus -60 over 2, which is 30. No, sorry, 60 over 2, which is 30. Now the period's 24 hours. In order to get information for our equation, we're going to go like our K value or our C value is going to be 360 divided by 24. Okay, so if we go 360 over 24, I get 15. So in the equation, we're going to deal with a 15. Okay, so I'm going to just quickly sketch what this would look like, okay? So we'd have 120, we'd have 30, and we'd have -60. This is the max, min, and equation of axis. Now, our initial point is 0, 30, which is convenient because this is our equation of axis. And it says that we increase first, then decrease, then decrease, then increase. Okay? And that takes 24 hours. So let's write an equation using our sine function. So we have y equals our amplitude, which is 90, sine, our K value, which is 15. We don't move left or right because we're doing sine and we're starting on the equation of axis. So no movement left or right, and then plus equation of axis. That's what I get. Okay, number 2, a carnival Ferris wheel with a radius of 7. So radius is 7, which is the amplitude. Makes one complete revolution every 16 seconds. So the period is 16, which makes like the K value in the equation 360 divided by 16, which I believe we found out was 22.5. Okay, and the critical intervals. The interval along the x-axis is going to be that 16 divided by 4, so it's going to be 4 seconds each. Okay. The bottom of the wheel is 1.5 meters above the ground. So that's the minimum point. The minimum point is 1.5. So here's the thing. If we have this Ferris wheel, and this is sitting at 1.5, then we got to think, okay, going up to the equation of axis is going to be like plus 7. So 8.5, so the equation of axis is 8.5. Now, if we go up another 7, so plus 7 again, we're going to get the maximum point, okay? So the maximum point is going to be 15.5. Okay, so 1, 2, 3, let's go 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14. Okay, so I'm going to go up by 2's along the side. This is going to be height in meters, and this is going to be time in seconds. Okay, I'm just going to label the minimum, which is 1.5. Okay, so y equals 1.5. I'm going to label the equation of axis, which is 8.5. Okay, y equals 8.5. Y equals a number because it's a horizontal line. Okay, and then we get 15.5 up here. Okay, y equals 15.5. So along the bottom, because our critical interval is 4 seconds, I'm going to go 4, 8, 12, 16. I mean, you can keep going 20, 24, 28, 32. Okay, and all we have to do is we have to pattern. Okay, so you board at the bottom, right? Sorry, we're going to find a sine equation for the graph, and then starting when the person gets onto the Ferris wheel at the lowest point. So that one is usually the standard. The question could involve getting on at the midpoint or the maximum, but here's the lowest point. So minimum, equation of axis, maximum, equation of axis, minimum, and you just pattern up and down, okay? So this is our graph. I personally like to do this with a cosine curve. So let's, this question asks for a sine curve. Let's do it with sine, and then let's do it with cosine as well. Okay, so sine starts right here. So it starts 4 seconds to the right. So we're going to have y equals amplitude sine 22.5, our k value or our c value. Okay, x minus 4 to the right. Right, and then plus 8.5, which is our equation of axis. If you did this exact one with cosine, you could forget about the shift left and right, and you can just simply reflect it, and then the cosine would start here at a minimum. So just the reflection, 7 cos 22.5x plus 8.5. Number 3, a contestant on The Price is Right spins the wheel. The center of the wheel is 1 point, so center, we're talking about the equation of axis. Okay, 1.5 meters above the floor. So our EOA is 1.5. He grabs the only red peg on the circumference of the wheel and pushes it downward. The red peg reaches a minimum. So here's the thing. This is giving us a little bit of a different information than the Ferris wheel, but same idea. The thing is the minimum is 0.25, and then they give us the equation of axis is 1.5. Okay? In order to solve for the actual amplitude, which is the radius, we would have to subtract those, right? So we get 1.25. And the other thing is if you wanted to find the maximum, we would have to take that 1.5 and add 1.25. Okay, so the radius is 1.25, but the diameter of that wheel is 2.5, maybe meters. Okay, it takes 4 seconds for the wheel to do 1 revolution. So the period is 4. Now the k value is 360 divided by 4, which is 90. So the critical interval is 90 over 4. No, it's period over 4. Period over 4, which is 1 second. Okay, so A we already did. What's the maximum height that the peg will reach? 2.75, it's meters. Okay, let's do C and D, and then I'm going to paste in a graph here, okay? So determine the equation of the sine function. Oh, actually, let's graph first, because then we can read the graph. Okay, let's go to B. Sketch 1 cycle of the graph, starting with the red peg being at the same height as the center. So the starting point is going to be on the equation of axis, and that person is pushing it down. Okay, that's important. So the maximum is 2.75. So let's go 0.25, 0.5, 0.75, 1. 1 1/4, 1 1/2, 175, and 2. 2 1/4, 2 1/2, 275, and 3. Okay, so here's our maximum, 2.75. Okay, our equation of axis was 1.5, and our minimum is 0.25. Okay, and then along the x-axis, we're just going to go up by ones. 1, 2, 3, 4. And we're just going to do one cycle. This is fine. Okay, so the person grabs the peg on the equation of axis and pushes it down. So it's going to go down to a minimum, back up to the equation of axis, up to a maximum, and then back down to the equation of axis. So a little bit different here because we can do a sine curve with the reflection here, right? Because the sine curve is just going down. So determine the equation of a sine function. Well, that's going to be y equals, amplitude is 1.25 sine. Our k value is 90, x, plus our equation of axis, which was up here, it's 1.5. Okay, but because it's going down first, we're going to work with the reflection. Now, we're going to use the exact same information. A lot of this doesn't change whether you go from the cos curve to the sine curve. Amplitude, equation of axis, and our k value don't change. All that's going to change is this shift. So if we're going from 0 to 3 seconds, we're going to have x minus 3 in there. Okay, number 4. At one time, the largest Ferris wheel in North America was located in Niagara Falls. The Ferris wheel had a diameter of 56. Okay, so and I'm going to put this on the right. If the diameter is 56, that means the radius is half that. So I think it's 28. Okay, here we go. One revolution took 2.5 minutes to complete. Okay, so the period is 2.5, which means the critical interval if we want to do it in minutes, if we want to leave it there, we can 0.625. Okay, and that means our k value in our equation would be 360 divided by 2.5, and it's 144. Riders could see Niagara Falls if they were higher than 50 meters above the ground. Okay, so this is going to be a piece of information. Okay, so let's come back to that. The rider gets on the lowest height. So the lowest height is, so the min is 0.5. And whenever we talk about time, we always talk about it starting at like time equals 0. So that's fine. Okay. Determine the time interval when the rider can see Niagara Falls. So I'm going to put equation of axis. I'm going to add the 28 because I'm going to add the radius, and then I'm going to add the radius again, and I'm going to get to the max. Okay, so 28.5 plus 28, we're going to get 56.5. So if I just wanted to sketch it, and this is a rough sketch, I'm not including everything, okay? So minimum, equation of axis, maximum. I would go minimum, equation of axis, maximum, equation of axis, min. Okay, that's what that's going to look like loosely. Our critical interval is 0.625. So I'm going to put 0.625 plus 0.625, 1.5 plus 0.625. Okay, so this is 1.25. And this is 1.875 plus 0.625. I'm making sure that that's, yep, it goes around to 2.5. Okay, so this is my time versus height. So what I would do here first is determine the time interval. Okay, I would create an equation. So I'm going to use the cos. So y equals negative, and I'm going to put a negative cos function because I don't want to deal with the left right. Okay, so the radius is 28, which is here. The k value is 144, so 144x. And then we have equation of axis is 28.5. Here's the thing. It's saying if you're above 50 meters, you can see all of Niagara Falls. So what we're actually trying to find is right here. We're trying to cut this off, and we're trying to find this entire interval. So when it goes from this point to this point. And remember, we're working with symmetry. So like one rotation of the sine curve is, or cos curve, is symmetric about any max or any min. So if we put in 50 equals negative 28 cos 144x plus 28.5, I'm going to rearrange this. So 50 minus 28.5 equals negative 28 cos 144. So we get 21.5 equals negative 28 cos 144. Okay, negative 28, negative 28. So I have negative 0.7678. Oh, sorry. There's supposed to be an x there. My mistake. Equals cos 144x. Okay, 144x is connected to one another, so we can't separate those. We have to cos inverse both sides at this point. So I get 140 equals 144x. Okay, and then divide out. I get 0.97. Okay, so at 0.97 minutes. So if you wanted to convert that into seconds, okay, so 0.97 minutes into seconds, what we do is we times it by 60. So this is 58.4 seconds into the ride, okay? I'm going to keep it as a decimal of a minute because that's what we graphed in, so that's fine. So here's the thing, and I'm going to zoom in. So if you take a look at this part of the graph right here, I'm going to zoom in. So what happens is we have some peak, and then it comes back down, right? And that peak occurs at I believe 1.25. So we're looking for this point where the height is 50, and then this point where the height is 50 as well. So if we go back using symmetry to 97, the difference between these two is 1.25 minus 0.97. I get 28, 0.28 of a minute. That means using symmetry coming over here, I'm going to add the 0.28. And I get 1.53. So let's go back to the question. Okay, so the original question says determine the time interval. Okay, so we're going from 0.97 minutes to 1.3 minutes. That's the time interval. So the rider can see all of Niagara Falls between 0.97 minutes and 1.53 minutes. Okay, number 5, Melissa used a motion detector to measure the distance between her and a child on the swing. She stood in front of the child and recorded the distance in meters over a period of time. So she could be here, and then the child on the swing would swing from here to here, kind of like a pendulum. So we're referencing, we're actually, instead of referencing this middle point, we're actually referencing where Melissa's standing. Okay, the data she collected are given in the following tables. Okay, so here's a really, really long table. We're going to write an equation for the sine function represented by the data, and then we're going to do the same thing for the cosine function. Okay, so when I'm thinking about this, I know I need an amplitude in equation of axis. I need the period, which gives me my k value, and I need any shift. Those are all of the possible transformations that I need in the equation. So when I'm looking through here, in order to find the amplitude and equation of axis, I'm actually going to look for a max or a min, okay? So what is the biggest number that we see in the y column? I think it is that 3.8, okay? So 3.8 occurs here, then 3.8 occurs here again. Okay, so maybe max is 3.8. Okay, now let's look for the min. So the smallest number is 0.6. And then, it reaches 0.6 again here, 0.6. So with this information, we're able to solve for the amplitude, 3.8 minus 0.6 over 2. And we're able to solve for the equation of axis, 3.8 plus 0.6 over 2. 0.6 divided by 2. So we get 1.45 and 2.2. Okay, amplitude 1.45, equation of axis 2.2. Now the period, when we're looking, we go from a max to a min and back to a max, and that's going to be one full rotation. So it takes 1.6 seconds to make a full rotation. So that's the period. So for the k value, we're going to take that 360 and we're going to divide it by 1.6. And we get 225. So right in our equation, we're going to use 225. Okay, for the shift, we have to take into account the critical interval. So the critical interval is going to be our period divided by 4. Okay, so this is like doing 16 divided by 4, which is like 4. So let's come back to shift when we actually put it into like the sine or the cosine function. So if we were to quickly just graph this, we do start at a max, and the max is 3.6, and the min is 3.8, and the min is 0.6, and we get there in 0.8 and then 1.6. 0.8, 1.6. Okay, the numbers in between here, well, they're 0.4 away. So 0.4 and then 1.2. Okay, so we're just adding 0.4 each time. So here are our equations. And this wants it with t and d. I'm not sure if I did the number 1 with t and d, but we're going to have distance at time t and distance at time t. Okay, amplitude doesn't change whether we're using sine or cosine, so the amplitude is going to be 1.45. Okay, the first one we're going to do is sine, the second one we're going to do is cos. The k value doesn't change. Okay, I'm going to leave a little bit of room for the shift. That is the only thing that changes. Okay, remember the sine and the cosine functions are identical except for their one shift. They're shifted one critical interval over from one another. Okay, and then the equation of axis is 2.2. Okay, so looking at this graph here, I'm going to say that we're done the cosine function. Okay, the reason why I would say that we're done this, so I'm just going to put an X there. There's no shift, okay, is because we start at a max and end at a max. So that's done. In regards to the sine function, sine starts on the equation of axis and it goes up first. So we can say that we started 1.2 seconds later. So x minus 1.2. Okay, because that's going to shift right 1.2. Okay, looking back at this, I recalculated my amplitude. I actually get 1.6. Okay, which just makes this number 1.6 and this number 1.6. Let's do it in purple. Sorry about that.